You are tuned to Iri-e-learning, and I am your host, Teacher. In this mole concept lesson, we will be calculating moles using the mole equation. Check the description box for links to all the videos related to this unit. By the end of this lesson, we should be able to calculate mole given the mass of the element or compound. Okay, as our learning objective stated, we're going to be using the mole equation to calculate moles. So what is the mole equation? Well, it states that moles is equal to the mass of the element or the compound in grams divided by the molar mass, which has units of grams per mole. And we saw how to calculate molar mass in a previous lesson. So if you're not sure, please review the lesson on calculating molar mass and relative mass. Now we'll show that the unit for moles is in fact moles. As we saw, the mole equation states that mass in grams is divided by the molar mass with units of grams per mole, which is actually a fraction of grams divided by mole. So our numerator is grams and our denominator is a fraction of grams divided by mole. When we have a numerator divided by a fraction, it is the same as the numerator, which is in grams, multiplied by the reciprocal of the denominator. So now we have, instead of grams per mole, we have mole per grams. And of course, we can already see that the grams will cancel each other, which leaves us with the unit mole. So our first example states how many moles are in 26.5 grams of sodium carbonate, Na2CO3. So what information do we have? To find moles, we have the mass, which is 26.5 grams. And next, we need to find the molar mass of the compound sodium carbonate. So when we do our calculations, we would check the periodic table to find the mass for 1 mole of each of the elements in sodium carbonate. The mass of 1 mole of sodium is 23. There are 2 sodiums. So when we multiply, we get a product of 46 grams per mole. The mass of 1 mole of carbon is 12 grams per mole. And there's only 1 carbon, so the product works out to be 12 grams per mole. Then for oxygen, the mass of 1 mole of oxygen is 16 grams per mole. There are 3 oxygens. When we multiply the quantity of oxygen by the mass of 1 mole, we get the product 48 grams per mole. Therefore, the total molar mass of sodium carbonate works out to be 106 grams per mole. So we can now use the equation to find the number of moles in 26.5 grams of sodium carbonate. So what we have, moles will be equal to 26.5 grams divided by 106 grams per mole. And that turns out to be 1.25 mole. Therefore, we can say there is 0.25 moles of sodium carbonate in 26.5 grams. Example 2, how many moles are in 1.5 grams of hydrogen chloride? We are reminded that moles is equal to the mass of the compound in grams divided by the molar mass, having units of grams per mole. In this example, we have the mass of 1.5 grams, and we can find the molar mass of hydrogen chloride. So let's go ahead and find the mass of hydrogen chloride. So we'll use the data from the periodic table where we can have the mass of 1 mole of each element within hydrogen chloride. As we can see, there's only 1 hydrogen in the formula, so we multiply the mass of 1 mole, which is 1 for hydrogen, by its quantity, and that gives us 1 gram per mole. We do the same for the chlorine. The mass of 1 mole of chlorine is 35.5. And we multiply by the quantity, and that gives us 35.5 grams per mole. Then the total mass of hydrogen chloride, we add all the values together, and we get 36.5 grams per mole. So back to our example, we now have moles is equal to 1.5 grams divided by 36.5 grams per mole, which gives us an answer of 0.0410958 mole. Now, when we have a long decimal number as represented here, we tend to round to at least 4 places of decimal. That is, we want to have 4 digits behind the decimal point. So we'll count 1, 2, 3, 4. Then we'll draw our imaginary line, and we'll look to see if the number after the imaginary line is 5 or greater. We will then add 1 to the digit in front of the imaginary line. So as a result, our answer would be 0.0411 mole. Consequently, we know that there is 0.0411 mole in 1.5 grams of hydrogen chloride. Note, if we have a long decimal number, as we did in example 2, and we're rounding it to 4 decimal places, what we would do if the number that comes after the imaginary line is less than 5, we just erase the digits after the imaginary line, and the digits before the imaginary line would remain unchanged. Example 3. How many moles are in 150 grams of sodium chloride? Once again, we have the mass, which is 150 grams, and we can find the molar mass in grams per mole of sodium chloride. Once again, we use our data from our periodic table, where we have the mass of 1 mole of sodium to be 23 grams per mole, and there's only 1 sodium, so we multiply by the quantity of 1, and we get 23 grams per mole. For chlorine, the mass of 1 mole of chlorine is 35.5 grams per mole. There's only 1 chlorine in sodium chloride, so we have a product of 35.5 grams per mole. The total molar mass of sodium chloride is 58.5 grams per mole. Consequently, the moles of sodium chloride works out to be 150 grams divided by 58.5 grams per mole, and we end up with 2.56 moles. Therefore, we have 2.56 moles of sodium chloride in 150 grams. Example 4. How many moles are there in 0.005 grams of ammonium sulfate? And we can calculate the molar mass of ammonium sulfate. So following the typical rule for finding the molar mass of ammonium sulfate works out to be 132 grams per mole. We multiply the mass of 1 mole of each element by its quantity, as we have laid out right here. Therefore, the moles of ammonium sulfate works out to be 0.005 grams divided by 132 grams per mole. And we get a very small number, 0.000037879 mole. When we have these numbers with many trailing zeros after the decimal point, we express such numbers in standard form or scientific notation, that is in the format a times 10 to the power of n. So what we do, we locate our decimal point and we move it in the direction where we can then get to place it behind the first significant figure. So here we go, 1, 2, 3, 4, 5. So we have moved our decimal point 5 times, which means that the value of n is 5, and it's actually -5 because we have moved the decimal point to the right of the number. Therefore, we know that the front number will be multiplied by 10 to the -5. As a result, we need to find out what a is. So returning to our number, note that the preceding zeros that are occurring before the first significant figure have no value, therefore we erase those. As a result, we are left with the value of a, and we would want to express this to 2 decimal places. That is, to have 2 digits behind the decimal point, we draw an imaginary line. Since the number after the imaginary line is greater than 4, we add 1 to the number in front of the imaginary line. So as a result, a is equal to 3.79. So the number of moles would become 3.79 times 10 to the -5 mole. Therefore, 3.79 times 10 to the -5 mole of ammonium sulfate is found in 0.005 grams. It's quiz time. You have 5 seconds to answer each question after it is read aloud. If you need extra time, pause the video at the start of the music and then continue playing the video when you are finished. Question 1. How many moles are there in 30 grams of carbon? A. 0.4 moles. B. 2.5 moles. C. 0.2 mole. D. 5 moles. The answer is B, 2.5 moles. How did we arrive at this answer? We know that moles is equal to the mass divided by the molar mass. Therefore, moles would be equal to 30 grams of carbon divided by the molar mass of 12 grams per mole. As a result, the answer is 2.5 moles. Question 2. How many moles of water H2O are present in 0.45 grams? A. 0.4 mole. B. 40 moles. C. 0.25 mole, D. 0.025 mole. The answer is D, 0.025 mole. How did we arrive at that answer? Well, first, we will find the molar mass of water, which turns out to be 18 grams per mole. The mass of each hydrogen is 1 and the mass of oxygen is 16. Therefore, we obtain 18 grams per mole for the molar mass of water. And as we know, moles is equal to the mass divided by the molar mass. As a result, moles will become 0.45 grams divided by 18 grams per mole, which gives 0.025 mole. Question 3. How many moles are present in 1.5 grams of sodium sulfate, Na2SO4? Round your answer to 3 decimal places. A. 0.011 mole, B. 94.667 moles, C. 0.021 mole, D. 46.667 moles. The answer is A. 0.011 mole. First, we find the molar mass of sodium sulfate, which works out to be 142 grams per mole. Then we can use our mole equation, dividing the mass of 1.5 grams by the molar mass of 142 grams per mole for sodium sulfate. The answer becomes quite a lengthy decimal figure, and so we round it to 3 decimal places by counting 1, 2, 3 after the decimal point. We have our imaginary line. The digit that comes after the imaginary line is 5 or greater, so we add 1 to the digit in front, which is 0. So 0 plus 1 gives us 1. As a result, our final answer to 3 decimal places would be 0.011 mole. Question 4. 1 mole of calcium carbonate has a mass of 100 grams. How many moles would be present in 0.0025 grams of the compound? A. 2.5 moles, B. 0.25 mole, C. 2.5 times 10 to the negative 5 mole, D. 40,000 moles. The answer is C, 2.5 times 10 to the negative 5 mole. How did we arrive at this answer? Moles, as we know, is equal to the mass divided by the molar mass. Therefore, the mass of 0.0025 grams is divided by the mass of 1 mole, which is the molar mass, which is 100 grams per mole. As a result, we have 0.000025 moles, which we will express in standard form as 2.5 times 10 to the negative 5 mole. Question 5. If compound X has a molar mass of 331 grams per mole, how many moles are there in 0.0005 grams of compound X? A. 1.51 times 10 to the negative 6 mole. B. 1.51 times 10 to the 6 moles. C. 6.62 times 10 to the 6 moles. D. 6.62 times 10 to the negative 6 mole. The answer is A, 1.51 times 10 to the negative 6 mole. We arrive at this answer using our mole equation where mass is divided by the molar mass. Therefore, moles is equal to 0.0005 grams divided by 331 grams per mole. This equals to 0.000000151 mole, and we express that in standard form as 1.51 times 10 to the negative 6 mole. Just remember, when we move our decimal point to the right, the value of n is negative. We have reached the end of our lesson. If you found this video helpful, remember to like, share, and subscribe. When you subscribe, you will receive notifications as new videos are uploaded. So until next time, I am Teacher with Iri-e-learning.